Alright, we've talked about galvanic and voltaic cells, and now I want to talk about an electrolytic cell. An electrolytic cell is just the opposite of a voltaic or a galvanic cell, in that the delta G for an electrolytic cell will be positive, meaning that it will be non-spontaneous. And if it's non-spontaneous, if delta G is equal to a positive value, then because delta G equals minus NFE, then E, the potential, will be a negative value, also non-spontaneous. If delta G is negative and the reaction is going forward, that means you get a lot of product and very little reactant. And so if I'm looking at K on a spontaneous reaction, you've got a lot of product divided by little reactant. K will be a large number, a number larger than 1. On the other hand, if it's not spontaneous, then you've got lots of reactant, very little product. So you got a small number divided by a big number, and so K will be less than 1 if it's non-spontaneous. In an electrolytic cell, oxidation is at the anode, just like we had in a galvanic voltaic cell. Remember anox and red cat? The difference lies in that oxidation at the anode will be positive. We're going to force the anode to be positive. We're going to force the cathode to be negative. So when I take a look at an electrolytic half cell system, I'm using zinc and copper here, and I have the two reduction half reactions. If this is going to be an electrolytic cell, we must have we must have E being a negative value. The only way to get this to be a negative value is to turn the copper reaction around. So I want to go from copper to copper 2 plus 2 electrons, and then the E0 will be equal to a negative 0.34. So now when I add those two reactions together, I end up with copper plus zinc 2 plus, giving me zinc plus copper 2 plus, and the E for this will be equal to negative 1.10 volts, right? And so what do we have going on here? We've got reduction happening at zinc. So we've got reduction happening up here, which means this is my cathode. And I've got oxidation happening here, which means that this is my anode. Oops, anode. Sorry about that. Which way are the electrons flowing? We're saying that the zinc 2 plus is going to gain electrons. So the zinc has to be gaining the electrons. So the electron flow is going from the cell on the right to the cell on the left. So electron movement is going from right to left, always from anode to cathode. That's the direction of the electrons. So the electrons are meeting up with that zinc 2 plus, and the zinc 2 plus is becoming zinc metal. On the other hand, we're stripping electrons away from copper metal, and that copper metal is becoming copper 2 plus. So the anode is disappearing on us while the cathode is increasing in size. So the only difference here between the electrolytic cell and the galvanic or voltaic cell is that I would have switched the cathode and anode around. On a galvanic or voltaic cell, the copper would have been your cathode and the zinc would have been your anode. We would have ended up with a positive 1.10 volt system overall on that voltaic galvanic cell.